Good evening, sir.
Yeah.
Good evening, one and all. Am I audible?
Yeah.
Professor SK Pal, sir, please respond. Am I audible?
Yeah.
But your voice is not audible to me. You are responding. I can see you.
No, madam, audible, madam. Pulsar's voice is audible. Madam, the voice is audible.
Okay, thank you so much, sir. Okay, so welcome back to the second day of ATAL FDP on Industry 5.0 and smart manufacturing. So today's lecture, our invited keynote speaker is Professor SK Pal. He's a very well-known professor from IIT Kharagpur. Everybody from whoever from IIT Kharagpur and apart from IIT Kharagpur, he's a very known personality. So I won't take much more time to introduce him. So Professor SK Pal is a distinguished academic and researcher currently serving as a professor in the Department of Mechanical Engineering at the IIT Kharagpur, a fellow of Indian National Academy of Engineering and former Lord Kumar Bhattacharya Chair Professor. He is renowned for his expertise in artificial intelligence and machine learning in manufacturing, along with pioneering research in brain computer interface application in the same domain. His research also focuses on experimental and numerical analysis of manufacturing processes, with special emphasis on fusion and solid state welding and wire based additive manufacturing. He has held significant leadership positions, including founder chairperson of the Center of Excellence in Advanced Manufacturing Technology since 2018 and previously served as Associate Dean of Alumni Affairs and Branding from 2018 to 2021. In addition to his responsibilities at IIT Kharagpur, Professor Pal holds visiting professorship at prestigious international institutes, including the University of Huddersfield, UK, then University of Connecticut, USA, and Lehigh University, USA. His extensive contributions to the advanced manufacturing, global academic collaborations, and leadership roles make him a highly respected figure in the field of mechanical engineering and manufacturing technology. So, may I now request Professor S.K. Pal to deliver his lecture?
Yeah. Thank you, ma'am. Thank you, Kit, for inviting me. My voice is audible, I believe.
Yes, sir.
Okay,
Audible.
so let me share the screen first. Is the screen visible?
Yes, sir.
Because I can't see any one of you once the entire screen is shared.
Yes.
But anyway, so once again, good evening to all of you, and I believe that all of you are the faculty members from the different the colleges, participating to this the FDP program, and the I must sincerely I must thanks to Kit for organizing such programs. And today I'll talk about the industry 4.0, industry 5.0, and smart manufacturing. Now, this the this would be the overall content of the my today's presentation. So it may exceed more than an hour, but I hope that it should not be much of a concern because it's in the evening time and it's on online mode. So now, since I can't see you, I can only see the screen. But my earnest request to all of you is that please, the focus your mind on the topic that I'm going to talk about today. The so that the I can create an awareness in you regarding the concern, if it can be infused, whether we can work together, whether you can take it forward for your career development, whether all of us can do something in the Make in India movement. So that should be the objective. It's not a just an ordinary lecture or a lecture of just one topic. It is to create an awareness that what is Industry 4.0, what do we stand in terms of the smart manufacturing, what is Industry 5.0, what is the potential, how much is the concern, what could be the possible use cases, so and so. Before that, I'd like to give you the introduction about the Center of Excellence in Advanced Manufacturing Technology. Those who have not heard of the Center of Excellence, they can virtually visit by clicking the website link coemt.iitkgp.ac.in and get to know that this Center of Excellence is mainly for the industrial research. When you talk about the industrial research, the dimension, obviously it is different than the conventional theoretical research or the experimental research that we carry out on daily basis in our the respective institutes. It is a research platform to create an industry academia collaboration. So I'd say it's completely dedicated to the dedicated to solve industrial problems since its inception in 2018, and I'm the founder chairperson of the Center of Excellence from 2018. We do have many industries working. Presently, 11 industries are working with us. They are very well-known industries in India, primarily Tata Group. Along with the Tata Group, some public sector organization is also there with us, and some other organization. If I want to take the name of the organizations, it is Tata Motors, Tata Steel. We do have the Blue Star. We do have the presence of USA-based company Amplo Global, and many such the organizations. So the vision of the Center of Excellence is to create the to make use of the modern concepts, primarily the digital concepts, into the field of manufacturing, so that we can bring innovation. And this for this we'd like to create an ecosystem between large industries, small industries, and academic institutes, so that we can all of us work together. At the same time, we from the beginning we wanted to give the training to the industry professionals, so that they can get to know what are the happenings in the digital world and how they can be deployed into the manufacturing field, specifically the micro, small, and medium enterprises, so that at the same time the startup culture can be built upon. So when you work together, obviously, the certain amount of innovation or the novelty would be coming up, and we file patents for the same jointly. There are many examples which I'll also showcase during my talk. So from the OEMs, we got we basically designed 4 thematic areas like the materials, automation, additive manufacturing, and Industry 4.0. So you got initially the problem statements from the OEMs, and our researchers, our faculty members worked cohesively with the researchers or the engineers of the OEM, and then solved together, and then and many of our solutions are deployed in the industries. And at the same time, as I've told, that we wanted to give training, nurturing the micro, small, and medium enterprises. We all know that micro, small, and medium enterprises are very vital in the manufacturing GDP of India. It's nearly 40%, but they are not very digitally savvy. Technologically, they are not very savvy. We often call that they live on the jugaad technology. So, in order to make them digitally savvy or the technologically advanced, so it is our responsibility, all of your, it's responsible for all of us, the faculty members, to come up with the technology which would be very, very low cost. Because the micro, small, and medium enterprises, their the capacity to adopt the digital or the advanced technology will not be the same as the capacity of the big industries. Big industries do have big pockets, financial pockets, so they can adopt technology very easily. But small industries, they think not only twice, they think many times before adopting the new concept. So our primary goal was to come up with the low-cost solutions for them. So this is overall ecosystem. This is a self-sustainable center of excellence. This is not funded by the IIT Kharagpur. This is inside IIT Kharagpur. This is an unit of IIT Kharagpur Center of Excellence. But from day one, it is running based on the project. You can understand that right now I was drinking tea. The cost of the tea is also coming from the project. That means we need to always think of the flow of money to the center of excellence, which is very, very critical. And when you have this sort of concern, and that you know that the money can only come from the industry, that means how much pressure we do have in bringing projects. Not only bringing projects, when the project comes up, responsibility increases. You have to deploy the technology into their practices so that you can get more projects in future. So there is a difference between the projects which are funded by the industry versus the projects which are funded by the government agencies like the DST, CSIR, or ACRB, or something like that. So here, the industry project, you have to solve the industry's concern. So for doing this, I wanted to create an awareness in all of your minds. Those who know it is fine. There is a term called the technology readiness level. You all must understand what the technology readiness level. In brief, we call it as the abbreviated form is the TRL, technology readiness level. It is metered from TRL 1 to TRL 9. And if you go through these blocks, TRL 1 to TRL 9, you will find mostly our research are TRL 1 to maximum 3. That means academic institutes, they are primarily concerned about the research which are having technology readiness level up to 3. And industry's needs is that 7, 8, and 9. 7, 8, and 9. So there is a gap between 3 and then 7. This gap is the 4, 5, 6. This is called the valley of death. This is called the valley of death. So one has to understand that how the academic, the institute's research can be translated so that it can be deployed into the industrial domain or the practice by crossing the valley of death. That is called the technology development. So this center is working as a catapult center. We call it as a catapult center. That means catapulting the academic innovation and throwing it or putting it into the industrial domain. If we do have this sort of work, then there will be a strong collaboration between the industry and academia. Otherwise, we can talk about a lot, but the industry academia collaborations will not exist or it will not work. So there is a lot of you can understand that there are tremendous the benefits out of it. If when you do such type of works, that means our students or the researchers, they would be ready to be accepted by the industries, and industries are also getting know that what are the relevant technologies and how to solve the challenging problems and all. So it is a win-win, the situations. And that's why the Center of Excellence, it is primarily running, I would not say the primary, it is the 100% running based on the funding from the respective industries. So if you visit our Center of Excellence, I would request that all of you at your convenience, you can come and see our facility. It is full of sophisticated facility and of dimension is the industry scale. We understood in 2017 and 18 that if you want to solve the industry's problem, infrastructure should also be the industry-like. That means there are big infrastructures. We do have a 3D printing machine, additive manufacturing hybrid, which can print any metal object, Dimension could be around 850 that means close to 1 meter. So you can think of the large structure printing is possible by our machine, and it's a very costly machine. We do have a very good CNC facilities and also the welding. We understand that welding is one of the critical manufacturing operations, fabrication operations step. And this there the the lot of problems in the welding area in terms of less automation. So how to make the welding process more automated, and more automated means the real-time data collections and getting more and more insight about the situations and all. So those things have to be very well understood. You see that there are two robots working with a job positioner. They are working very cohesively and then doing the welding. So you can have robot to robot collaborations. So the this twin robot arc welding facility we do have. We do have the robotic, the spot welding facility. And you see the robot size of the robot. That means it does have a lot of, it can exert huge amount of the pressure, so it can very easily do the spot welding. And we all know that the spot welding or the MIG welding or the TIG welding do have a lot of applications in the various manufacturing sectors, specifically in the automobile sector. You see, this facility is the vibration testing facility. It's a huge robot. Robot does have the laser scanner, so it can scan in an object like a big car. And if the engine is on, it can be able to it can tell you that where from the vibration is coming up. And if you know the sources of vibration, if it crosses the limit, you can make the design changes and all these things. So these sort of facilities, very state of the art, many facilities are first time in the India. So having this facility, we thought that how to take the manufacturing into a completely different domain or the perspective. That was our the thought process. Now while doing that, we understood that how the evolution of manufacturing has taken place. All of us need to know that how the manufacturing has got evolved. And manufacturing is one of the very interesting and beautiful subspecializations, because it is, I would say, it's a very much transdisciplinary in nature. If you do research on manufacturing, you need to work on the thermal aspect, you need to work on the design aspect, you need to work on the material aspects, and many more aspects. And these days, since automation is coming up, you need to have an understanding of the electronics like the PLC, different types of the sensors, integration with the process, data collections, correlation with the physical phenomena. All these things are coming up in a picture. Now, manufacturing, the term or the manufacturing process, I would say, it got started long back in the prehistoric era, in the starting with the Stone Age. And at that time, only one cutting tool was there, cutting tool material was there, that is the stone. And during that period, people, prehistoric era, so they worked on the different dimensions of the stone over a period of time, huge amount of the time. And then they came up with a particular dimension of the tool or the shape of the tool, which can do many work. Like it can be used for the cutting, it can be used for the hunting, it can be used for many more activities. And those who work on the in the the mechanical engineering manufacturing, those who are aware with the cutting tool signature or cutting tool geometry, we all know there is a concept called the term called the rake angle or the clearance angle or the nose or the tip of the tool. All these things, those things actually did exist during that prehistoric era in the Stone Age itself. If you think that they came up with they didn't have the formal research, but over a period of time they realized that the any object, if it can be used for the cutting, it must have a sharp edge. It must have a sharp edge. So that's sort of they created the different dimensions of the different shape of the tool. From the Stone Age, they migrated to the Bronze Age area. And you see, the bronze is a concept, is an alloy, copper and then tin. So the concept of alloying did exist long back. And they understood that instead of using pure copper, which is pretty costly, and if I they use copper and a certain amount of the tin from the nature earth, then it is bronze is giving the better quality than the pure copper in many applications. So that's why the Bronze Age era people did a lot of the work, came up with the different types of the tools as well. Then the thought process got changed over a period of time. So people started working on the iron. Primary reason is that the iron, ferrous-based material, or the Fe ore is, very easily available in the nature earth in abundance as compared to the copper. Now, up to the stone, bronze, and iron age, whatever maybe the tool got generated and all, everything got done manually. Everything, not only the cutting tool, fabrication. Please mute your microphone, whoever is on. Please mute your microphone. So the whatever maybe the material or the cutting tool shape, it was everything was manual. Like if I want to cut an object, I need to rotate that object. I need to hold that object. So that was done manually, and the movement of the tool, everything got done manually. People then started designing of the mechanisms, and the mechanisms are run by manual, either by the human being or by the animal. And you all know that how difficult it is to tame an animal to do a job with the same frequency, same speed, same enthusiasm, and over a period of time. It's not so much possible. Then actually the industrial revolution started. Industrial revolution started from the industry 1.0 when the steam got used. That means the steam is used to give energy to the mechanisms for its movement, for its movement. Now, when the animal power or the human power is replaced by the steam to move the object or to give energy or power to the system, then lot of productivity increases. Then from the steam is very difficult to transport from one location to the other location. So, but vis-a-vis, if you consider the electricity, it is good. So when electricity came up, the electricity got started getting used in the industry. Then the mass production became very much useful. So that means one industry can be at Bhubaneswar, another same industry can be at Kharagpur, and they can be both powered by the electricity, and the simultaneously the production can happen. So, but if you want to have the industry, same industry powered by the steam, then we must have the same, the different power steam generating plant. One would be at the Bhubaneswar, another one would be at the Kharagpur. But in case of electricity, it can be one electricity generating plant. So that's the industry 2.0 era when the electricity got used, and we, as a common sense, we got to know that a lot of productivity increases, mass production, became very much popular. Then the mechanisms got robotized. A lot of electronics came up, computer came up, PLC, programmable logic, came up, and that's the era industry 3.0. Typically, the era is 1969 onwards. So 1969 onwards. So you can understand that if the robot comes up in the manufacturing domain, that means perfection is the term called the perfection or the precise operations is become very much prominent. Now, having this, the up to the industry in the industry 3.0 era, everything was very much programmed, hard programmed. Like if I want to move an object from one location to the other location by a robot, I have to tell specifically where exactly the job is, what is the orientation of that job, what is the shape of the job, how to grip it. Everything has to be coded, hard coded. If some changes are there, that means the job is not located at the exactly at the same location where it was supposed to be there, then the robot will not be able to pick it up. So that means it lacks the intelligence. So people then started thinking that how to overcome the drawbacks of the industry 3.0 era. And people started deploying the network, deploying the sensor. These days network is very cheap. All the time we are on WhatsApp, mobile, we don't talk each other. The husband and wife sitting side by side, and everybody's, both the fingers are on the mobile. If you see on the railway station, nobody talks. In the train, nobody talks. In the flight, nobody talks. That's the culture we are having. We are always on the WhatsApp. We are always on sending photos to near and dear one, taking selfie, this and that, and all the time we are very much busy. All these things are happening, whether it's a good or bad. I'm not commenting on it. All these things are happening because of the network, fast network. That means the data can be transmitted, text can be transmitted, image can be transmitted, video can be transmitted from one location to the other location very easily. And that is the cyber. And all these physical network, physical systems, like if a machine is there at Kharagpur, another at the Bhubaneswar, both can be connected by the same cyber facility. That means this is called the cyber physical system. So a lot of physical systems are connected to the cyber and collecting information. If I put sensor, getting the data, transmitting to the cloud, and from the cloud means it's a common place. And from there we can download it. So very fast you can acquire the data to the different deployment of the different sensors and putting it into the cloud, and from there you are getting that information. In this way we are getting more and more insight about the system, whether it's an academic institutes. This is also a system. Whether it's a, let's say the industry, it is an industrial platform. Whether it is a machine. Machine does have the different components. So from a particular machine, we are getting a lot of information. We are getting current consumption. We are getting the level of vibration. We are getting the temperature rise. If it is a the manufacturing shop floor, collections of machines, so how the different machines are working, what is the downtime and all. If it is an academic institute, how many students are present in a class, immediately we can get it through the data deployment of the data. So, and this is called the industry 4.0 era. That means getting more and more insight about the system. So when I can get more information, obviously, my intention would be to know better and better to make the process, the faster and the better and the productivity cheaper. So from the manual operations, machine age era, when the mechanisms were run by the human or the animal, there are some advantages and then some disadvantages. We can, if I apply our common sense, we'll get to know what could be the disadvantages and all. When you are stuck up with the disadvantages like the heavy weight, then cutting of the metal, and then maintaining the accuracy by the manual intervention is to be, the mitigated, then people thought of the mechanizations, like the steam engine can be used, steams can be used. And again, I have told the drawbacks of the steam. Then the people started using the electricity motorized. You know that the motorization means the productivity increase, but it is not fully automated. So that's why people now from the electricity to came up with the robotic system, robotic systems, that the PLC based system, continuously data collecting and all. But that is also not the ultimate. What is the ultimate then? Robot has to have the intelligence. So that means robot can take decision by itself. So that is the era we are standing in the industry 4.0. Question comes up whether that is the ultimate. But we'll try to find out the answer at the end. So the purpose of the society or the manufacturing industry rather, that how to make a process faster, how can I make the product at a cheaper cost, how can I make the product better. All the time we are in the race of making it faster, cheaper and better, faster and cheaper and better. And that's why you see the all the time the high production, making coming up with a cheaper cost. But nobody talks much about the quality. Nobody talks much about the quality. Even if you go for the, go to market on daily basis, in the vegetable market or the fish market, specifically we the Indian people, wherever the cheaper thing available, we first go to that place, the shop. At least that is the cheaper one. So this, in order to make a process faster, cheaper or better, you need to have a lot of understanding. You can't say that only if I'm a manufacturing engineer and mechanical engineer, I'll be able to solve it. Answer is no. You must have an interdisciplinary, and I would say the transdisciplinary, the research concept, so that you can put several, you can take up several approaches to mitigate the concerns and fulfill the objectives like the high productivity, low cost, and bringing the flexibility in the system. So that's why people are more interested about the artificial intelligence system. I understand, because artificial intelligence is no more a buzzword. It has pervaded even into a kitchen. Daily basis we are using it, and we are very much familiar. So I presume that all of you understand what exactly the artificial intelligence is. But just a quick, the comparison between the artificial intelligence and the human intelligence. Artificial intelligence is nothing but a computer program. Nothing but a computer program. This computer program or the algorithm is trying to mimic the functionality of the brain. So who is giving this information? It is the neuroscientist. So neuroscientists, the doctors, they do a lot of experimentations on to understand the functionality of the different portions of the brain. Computer science people or related, the areas, the expertise, they work with the neuroscientist people and understand how the brain works, and then coming up with a mathematical analogy, that is mathematical program. And we, the end user, the manufacturing engineer, chemical, civil, mechanical, and all these things, we are trying to deploy it into our own systems and see the betterment. But how the betterment? Like if a human is there, how to see, how a process would be evaluated by the human, whether that can be done by the computer program. So that's why these people are, since it's a lot of developments are taken place in the recent the decades, and from the simple neural architecture to the machine learning concept to the deep learning concept, now the GPT, the generative pre-trained transformer model GPT concept. So a lot of developments are happening in the computer, the AI algorithms, and that's why it is coming very fast, a much simpler way into our kitchen, the activities. Everywhere you go, go to you can find out that is the AI deployment. If you search something in your Amazon, it will the next day it will just give you that advertisement. It may happen someday. It is my vision. Like if I think something, and maybe the Amazon will get to know what I'm thinking. It's not surfing, I'm just thinking. Next day Amazon will, maybe through the drone, it will, the same product or the similar type of products will be coming up to your drone, coming up to your doorstep by drone. And whether if you really need it, you can see it. If you need it, you pick it up, scan the product, pay through the Phone Pay or the Google Pay, and the drone will fly back. And this way, everything, entire system would be fully automated. That means your thought process, your understanding, your thought process, you are not sharing with anyone. Still, Amazon will get to know. Amazon will get to know means the drone will get to know. Drone means the robot will get to know. What does it mean? It means that a machine can understand what you are thinking. That the days are very nearby. So the system, artificial intelligence system, has to understand what is happening. When I develop an AI system for some process or for something, some, the activities and all, so it must understand it. What does it mean? That means that meaningful insight can be derived by the AI code. It must be able to reason it out. And if it can reason it out, then the same algorithm can also co-work with the other algorithms. That means one system would be able to interact with the other system. If these features are there, then the AI algorithm can be called as the human-like algorithm or the human-like intelligence. So artificial intelligence would be called as similar to performance-wise the human intelligence if the artificial intelligence does possess the understanding capacity like human, reasoning capacity like human, and interacting capacity like the human. So the strong features of AI, if you see, is these features are very much common with the human. We can generalize knowledge. That means what we understand from the different circumstances, we can apply that. Maybe completely contrary situations, completely different situations. So if I understand something, the experience which I gather, I can make use of it for the future. Completely different domain. I can change, alter, or adapt to the circumstances with the previous knowledge of the experience. I do have the ability to reason it out. I do have the ability to solve puzzles. I also exhibit the common sense, and I do have a little bit of consciousness as well. So if an AI model can be developed incorporating the following features like the generalization capacity, this altering capacity, the reasoning capacity, the analytical solution capacity, and making it conscious, then AI model would be the human-like model. So, but let us gradually, from the very philosophical concepts, let us come down to the reality. These days, if I consider the manufacturing or the industrial domain, you see the left-hand side is the present scenario. That means how much AI has pervaded into the manufacturing domain, industrial domain, and how much is to be achieved, yet to achieve. Like the object recognition, machine health prediction, optimization, tool path optimizations. These are all some of the examples. I'm not saying the only this much has been has been solved. These are the similar, same type of example. The AI is very much doing good job. But AI is not so good in the collaborative platform. Now, when you say the collaborative platform, that means a robot will work with another robot, or a swarm of robots, or multiple robots, and so how do they interact with each other? In that platform, it is not very much strong. Even if I consider slightly beyond, the robot will work with the human. Actually, the cobotic terms came up from that itself. So when a robot will work with a human, you all know that a robot can be programmed, but human mind cannot be programmed. If a robot is there in any industry, same robot will be working with a different human at different shifts, morning shift, evening shift, night shift. And in a shift, robot can work flawlessly, tirelessly, with the same perfection level. Human cannot work. First 1 or 2 hour, 2 hour, human may be very attentive. After that, human mind will be thinking that when to check the WhatsApp of the near one or the dear one. Then gradually performance and all these things will get, it will start falling and falling and falling. So how to cope up with that situation? What is the intent of the human being? How does a robot get to know that what the human is thinking? So these are the critical questions coming up in the minds of the researchers these days, both in India and in the globe, that how to solve these situations, how to come up with a very good collaborative, the platform. How can a robot will learn by itself? Can I create the twin concept? That means digital twin concept. That means if I do have a system, and if I create physical system, if I create the digital version of it, from the digital version, I can predict that what can happen to the physical systems in next 5 minutes time. Okay, so that's whether does it, the concept of the simulations or the data collections, whether these will actually help if I use them together. And similarly for the, if we get to know all this, we can monitor a process very quickly and we can make it adapted for the control perspective as well. So there are many, having this sort of understanding of the potential of the industry 4.0 or the AI in manufacturing, people have started thinking that the application domains. You might be wondering, and in fact we had written a very good review paper. It's a 98-page review paper. If you are interested, you can go through that. Critical review of AI in manufacturing. If you search it, you will get it. 98 pages. There in details, we have mentioned about the different algorithms and the different sector like the casting, forming, machining, welding, additive manufacturing, and supply chain. What are the different possibilities of AI deployment and how much it has pervaded and in which direction the AI is moving to. So if I take the example of the casting process, the casting, when the casting is getting done, solidification is getting done, and during solidification, product may come up with the different types of the defects. So how to know when the solidification is getting done, that defect may come up? If it is so, how can I control or tune the parameters? If how do I get to know the defects of the cast product? How do I know whether the pattern dimension is absolutely perfect, whether it is given the proper allowances or not? So the checking the dimension, checking the allowance, checking the defective part, real-time process monitoring can be very easily deployed into the different domains of the casting process. If you see the forming, those who are working in the area of the forming, if it is a rolling process, you might be wondering to know how to get the complete physical description inside the process in terms of the dynamic recrystallizations happening when the material is getting deformed during rolling. Is it possible to get to know from the sensors data? When the incremental forming is getting done, whether defect is getting formed or not, whether the chances of getting crack formation would be there or not. And similarly, many more like the defect, inspections, quality of the form products, and when the many robots would be working together, handling the products and the basically the raw material, whether the material handling is posing a concern to the form products or not. If it is a machining, a lot of people do research on the machining. So how much is the tool wear in the dynamic scenario? So what is the surface toughness it is producing? How much is what is the chip, color of the chip? Is it different from the normal one? Is the machine vibrating a lot? So if vibrates, then what will happen to the product? So all these informations you can very easily find out by the AI deployment. If it is in welding, then there will be a lot of the possibilities, both before welding, during welding, and then post welding. Before welding, you can get to know whether the products which are to be mated or welded, they are having properly this good surface, edge finish or not. During welding, you can get to know whether the deposition is happening rightly or not. Post welding, you can get to know through the radiography testing or the ultrasonic based testing, and then coming up with the images. Those images can be tested by the AI software, which will be able to tell you that whether it is defective or non-defective. Now, the if I see the areas where AI can play a role is that the in industrial app domain is huge. It can be deployed in the automation, it can be deployed for the data analysis, predictive analytics, customizations for the product, which is very, very critical these days. So these days, the mass customization is the concept rather than the mass production. So in an assembly line, you'll get to know, you'll get to see that the maybe two products are consecutive in line may not be the same, having the same requirement. So how to allocate or assign the inventory for that? how to optimize the process line for to handle the different products. Like if we take the example of the car, so one car may be for the Indian market, next car may be for the foreign market. That means the dimension type of the tire should be the different. Their road condition versus Indian road conditions. Their shock absorber. So whatever the fitting should be there, it has to be done in the same cycle time. Think of the complexities, that how the supply chain system, how the technology, all these things can be aligned to tackle the customization or make it a flexible manufacturing system. So think on that aspects and then get to see that there will be a plethora, there will be a lot of application domains which you can start thinking and working. Process optimizations, you can always come up with an innovations, make it more and more autonomous. But at the same time, you have to be concerned about the data. The data which you are collecting, it has to be properly secured. Now, so there is a good hope, and that's why 71% people over as per the survey, it is thought that they are very much optimistic that AI will do a good job. And that's why 64% people out of 71, they have already started deploying the AI into the manufacturing domain or the industrial domain. Globally, there is a huge projection for investment, 3.7 trillion US dollar by 2035. So that means huge amount is going to be invested. Where? For the AI deployment. What does it mean? There will be more and more jobs coming up in the sensor development, semiconductor industries, electronics, and then your the low cost thing and all, and then your the all sorts of sensors, including the cameras, and then data collections, computer systems, then analytics. All these things should be coming up in a big the way. But there is a fear also. 36% people think whether AI will do the really good job for them or not. And these 36% people is primarily the micro, small, and medium enterprises. And and we all know that our micro, small, and medium enterprises, they believe on the Jugaad technology. So how to integrate the AI system onto my existing one? I do have an age-old machine. So the legacy machine, how can you make the legacy machine smart? That's the concern. I'm a small, I'm running a small organizations. I do not have much of domain expertise. So who is going to analyze that? The data I can collect it. Question comes up if I'm running an MSME, micro, small, and medium enterprise. Let's say the small enterprise. Who is going to analyze the data? How do I know the data is correct? Because the entire analysis algorithm works on the data. Who says that the data quality is good, data sanctity is good? I'm having a machine. You have developed an AI algorithm for it. I'm using it. Next day, I'm changing the same machine, same type of machine, but the new machine. Can that algorithm work? These are the concerns actually bothering many industries, and that's why our Center of Excellence in Advanced Manufacturing Technology at IIT Kharagpur, we all the time think on these aspects and coming up with the AI model, which should be very low cost and which could be generalized across. That means an AI model, if I develop for a milling machine, it should be applicable to all milling machine irrespective of the make, manufacturer, and of its age, irrespective of the age. So our research we are doing on many areas: process monitoring, machine vision, data analytics, robotics, digital twin. If you see the process monitoring, this we have worked with the Tata Consultancy Services. You see the technology readiness level. Each and every work we meter it by the technology readiness level. That means we work passionately. We keep out our emotion. Like when you understand that this is an industry's concern, we work very passionately and all the time think that how to increase its, the how to cross that valley of death. That is the technology readiness level 4. This is a friction star welding process, solid state joining process. When the welding is happening, it was giving some defect. You see the left hand side, there are some defects. But as the machine welding gets done, there is no more defect coming up. That means machine collected its data automatically and analyzed it automatically, giving feedback to that machine to run with the different parameters so that it can come out with a defect-free weld. So we have patent, both US patent and India patent with the Tata Consultancy Service. There are many publications jointly. We have published a book as well. If you're interested, you can just go through that digital twin. It is one of the books which is highly downloaded, at least 20 downloads per day. Initially, it happened like that. The only book in digital twin downloaded got so fast. Then these are many other process-based activity, like the a gearbox is there. So how to detect the gearbox the condition, collecting the motor data, collecting the various other the sensors informations. If you are doing it's a warm process, where are additive manufacturing? So through depositions of the material layer by layer, from the working principles of the welding. So how to detect the quality, how to check the surface quality of the warm process. If you are doing it, friction start based back extrusion process, solid says it's a very new process we invented, friction start based back extrusion. That means how to do the cladding of the, the tube surface, tube internal surface. And there itself, we can come up with the how to find out the temperature distributions and all. This is a you see the technology readiness level is 9. We developed an AI software first time in the world, which can detect the defects from the radiography images of the weld with a human-like accuracy. That person who was speaking, giving an interview to the industry, it is from the Garden Shipbuilders. This has been jointly copyrighted. It has been certified by the Indian Register of Shipping. If it is a software is certified by the third party, that means no one can challenge the accuracy or performance of that software. So this has participated in many of these. In fact, all participations it came up with an the awards. This is the product we delivered to the Tata Motors Jamshedpur, to how to read the text of the tire, and do the downstream, the analysis. Reading text from the tire in the shop floor is very, very critical. Apparently, it looks like it's very simple, but it's very critical. So this product, it has been developed. We have done one the very fast work in sometime during the COVID, that if we capture the image with a low cost camera like the webcam, if you see, these are the images of the wheel rims. On the left hand side, the topmost one is the image taken by the webcam, and just below that it is the image taken by a high quality camera, the Nikon. But we worked on the webcam image, blurred image, applied the AI algorithm, improved that image quality, and with that we went ahead with the checking the quality and came up with a 99% accuracy. So we participated in all India basis AI competition and came out as one of the top 3 innovations in the country, which is ready to go to the market. This we have filed as a patent. And all our works are integrated with the robotic system. That means the detection, the data communication, processing, feedback, all these things are happening within the cycle time. Many a times we work on the AI algorithms, many people work, but it takes so much of time, it can be deployed into the manufacturing domain. This is another work our intern students have done it, like how to check whether the printed circuit board, PCB, all components, everything are well placed, whether any component is missing or not. So how to check it for the mass production. And we file it as a patent, this product. Then fuse box assembly is giving 100% accuracy. Fuse boxes are used in the automobiles. Each of the fuses are for the different purposes and all. So how to get to know whether the right fuse is there at the right place or not. This has also been filed as a patent. Then inspection of the chassis dimension. Chassis is a long member of an automobile. So how to measure the dimension of that? Presently, people are going for the manual method, but we came up with an image processing based and gives you the accurate dimensions of that. Then many such the applications. So you can see that all our activities are for the industries. So we understand that what is the industry's concern. We discuss with them almost on daily basis, get to know the problem, and then start working. Many of the projects are not funded, but we have taken up the students, our intern students, doctoral scholars. They work very cohesively using the existing infrastructures. We sign NDA, non-disclosure agreement with the industry, get the data, and then come up with the solutions. And then we again go back to that industry and then tell, hey, we have solved your problems to 20% or 30%. Are you interested to giving us a project? So our striking rate is also very good. It's close. The other day I was checking it is close to 75%. That means the almost three-fourths of our project proposals got sanctioned by the industries. Now the signal processing, vibration data analytics. This is the software we developed and deployed in the Bokaro steel plant. Real time the vibration, the analytics on the vibration data of the exhauster fans. And it predicted the defect 23 hours before the phenomena. So accurately, and it happened. So this, this has been done. You see the technology readiness level 9. We have deployed it to the Steel Authority of India Limited. This is the, the AI software for identifying the welding defect, but from the ultrasound. The previous one from the radiography X-ray, this is from the ultrasound. Now, ultrasound, there are many images would be coming up because ultrasound is user-friendly as compared to the X-ray. And so huge amount of the data, who is going to check? It is not possible by the human being. As of now, throughout the globe, it is done by the manual method. So this, our patent has got granted and we are going for commercializations of this one. For the robotic, as I mentioned that these days robots are very much programmed. So that means robot knows that where exactly will be the locations and accordingly it will work. But if something changes, let's dynamically changes, you don't know where will be the exact location, what will be the orientation of the job. So how do the robot will get to know? And that too also with a minimum sensorizations. Here robot is mounted with a webcam. You see that the job is going there with the different rotations, different shapes, and then there is no specific orientations of that. But robot exactly goes there, picks it up, changes its gipper and picks it up and all. And if you'll see that the other, now it's a rectangular job at going to different locations. Here also now is a circular job, again going to the different locations and all. Robot is exactly going there. And so these sort of intelligence we are trying to bring into the robotic thing. So the robot can, through the sensorizations and all, the robot can, identify just like a human. Image is just like a photograph. So the camera is just like an eye. So through this, whether it can do these jobs or not. And the many such applications. Do you see? I'm throwing object at different locations. Robot is exactly going there. Robot is fitted with the webcam and flawlessly working without any programming. Without any program. This is called the intelligence system, autonomous system. So data capturing, job identification, data capturing, data processing, data communication to the cloud, again coming down to the communicated back to the robot and actuation to the robot. Everything is happening within the cycle time of the production. So this we have developed during our COVID time. So we did lot of the applications for the industries on the AI in manufacturing. So the location is not fixed, orientation is not fixed. So the for the paucity of the time, I'm just the skipping some of the slides and all because too many applications are there. So coming to this, the from there, I'd like to come to this, the Industry 5.0 or the cognitive AI concept. Now, as I mentioned that the AI models are developed. Basically, the AI algorithms are inspired by the functionality of the brain, and then functionality of the brain are explored to us through the experimentations. Like the microscope has given you the neural connections. From there, we get to know the how the artificial neural network structure is. So for how the dendrites and dendrites are connected to the body, and then how the information goes to the action, and then through the next neuron and all these things. So that can be, and then we manufacturing application, the process monitoring, then your fMRI give you the memory module, then LSTM model got developed, which is used for the time series forecasting and all. Then two photon imaging, from there we get to know the continuous learning. But you can now understand that the performance of the AI algorithm is purely dependent on how we are coding the functionality of the brain. If I am clear about the functionality, like the different parts of the brain, frontal, parietal, temporal, occipital, all these lobes, how the neural connections are, how many neurons are there, and how are they connected, how do they do the job, like how an information can be memorized, how the human can focus or give the attention to some object and all. So if I know that neurodynamics very clearly, then depiction of the neurodynamics by the AI algorithms can be done. So as of now, the accuracy or performance is purely restricted by our understanding about the brain. So future day coming up with the people are working on the very much AI augmentations, as I've mentioned, that people are trying to make it more human centric. And if you want to make it more human centric, you have to have a very good expertise or algorithm development of the NLPs, natural language processing, the dialects, the speech, the all things like the PDF text, our languages, and country like ours is very very challenging. you know Processing English text is something, but processing Bengali text, or processing, let's say, the Odia text or the Telugu text and similar other for the different states and all, and to make it more uniform by the AI model is a challenging thing. So these are all our country's problem. So that's why whenever I go and deliver a talk, I always tell that the AI success of AI in India will depend on how Indians are working for Indian problems. So that means any academic institute must work for the technological deployment for that society. It is a responsibility, and that's why the different institutes are there. Yesterday I was I was discussing with the high officials in the Delhi, and I told that the different IITs are there, and the different IIT, every IIT almost now has the different states similar to the NITs, but hardly we are engaged in solving the problems of the states. What does it mean? I'm not talking about the political thing. I'm talking about the potential of that particular state. Like our, the West Bengal and different districts and all, they are having agricultural thing. They are having the Dokra thing. So how the technology can be brought into the agriculture, AI for AI. That means AI for agricultural innovation. Are we really doing that for our own country? If it is to be deployed in the micro, small, medium enterprises, do you have, because a lot of informations are available through the different expertise, can I capture those informations? Can AI model understand the dialect of the worker? So these are the concerns the are coming up. So that's why we are Center of Excellence. We are working on that. Can a robot understand my thoughts? So what I'm thinking, if I'm thinking of some color, red, green, or thinking of some image, and the robot will draw that image. These days, GPT, the generative pre-trained transformer model, in a chat GPT mode, that means you are chatting it, you are writing something, and then GPT gives you the information. If you are putting an image GPT, it will give you another image. If it is a signal GPT, if you're giving a signal, it will generate another signal. So these things are happening. And beyond that, is it possible by a robot to get to know what I'm thinking? So is it possible that your soul will also be available in the Amazon or the eBay in coming days? Can a machine be made conscious? In my understanding, it is very much possible, because if I can document properly my own action plan and store it, the next generations, the expertise can also can be very easily transferred. The way we preserve the books, book is a philosophy, is a concept, and that the generations over the generation read the same book and understand it. So an experienced worker's working plan, working methodology, if it can be properly documented and stored, and then one day we can come up with the thing. You see, it is happening now. I am sitting in my lab thinking of the red color, what is exactly picking the red color. So there is no other connection, no other info. I'm sitting it wearing an EEG cap, electroencephalogram, during the COVID time. And the what I'm thinking, when I'm thinking red color, EEG, the brain is processing that my observations and emitting some signal through the scalp, and that signal I'm capturing, and it is transmitted to the cloud, and then that information is processed by the robot, and robot works on that. So we are working in these domains, like if a machine produces sounds of different nature, like if a fan is there, when the fan is the if it's a new condition, it would be there may not be any sound, but over the years, because of the problems with the wear and tear in the bearing balls and the bearings and all, there will be some funny sounds coming up. So if when I think that the sound is very odd, let me switch off the fan, or maybe reduce the speed. When I'm thinking, I'm not telling anyone, the fan itself will reduce its speed. Fan itself will, the stops its, the operations and all. So these things are very, the nearby. When I'm thinking of a image of a cat or image of a dog, robot gets to know that. So it is my vision. So these I prepared when I delivered a talk at NIT Durgapur. The days are coming up where the soft floor would be very less with presence of the human, and even if the and human would be there as more of a supervisor in nature, and communication between the human and then robot would be more of the thought level, like there would not be any verbal communications and all, you see. So the operator is coming into the welding lab. Initially, the operator is saying something, that to operate the robot at a certain speed and all. Robot decides whether I should follow the operator's instructions. What is my health today? That is the health of the machine. If I'm unable to operate in that, the process parameter, then I should change the process parameter. You see, this is the video, animated video, we have made it. Then it's running a digital twin. So this is the thought. This now the thought is captured. Now this information is going to the cloud. The operators, the expertise, and in future in Amazon you can download that information. So the coming days are there. The robot and the human, they will work together. Robot will understand your emotion level. So if the robot finds you are not in good mood, robot will act accordingly. And they will also work together. They will not only coexist, cooperate, or collaborate. They will also be compassionate, and at the same time they will also co-evolve. This we call it as a 5C work frame. So 5C work frame is, as of now, it's a 3C where we are working together. But robot is not the compassionate to the human. And robot is also not changing its work plan. You see the dance. So robot and human working together, they'll be dancing together. And the human will understand the best dance posture from the robot. And robot will also try to understand the how human is dancing and changing its dance plan. So the machines will be conscious and work, with a human, like a human in coming days in the industry 5.0, the era. Thank you so much. With this, I'd like to stop. Hope you all have enjoyed. If you'd like to reach to me, these are my digital, the connections. So you can get back to me at any point of time. Thank you so much.
Thank you, sir. On the behalf of the organizing team, as well as all the participants, I, Dr. Smriti Pradhan, extend my deepest gratitude to sir for giving such a nice talk and spend some time for us. Thank you, sir. You are not only just for an exceptional or academician, but also a true mentor and a role model for us. Thank you so much, sir. I am extremely happy after listening all your talk.
Okay, thank you. If you have got any question, anything, I'll be able to answer. I'll try to answer. If not, you can also write to me. You can search me in the Google and get to know my email ID and all. But I would request
Sir,
that you are
yes,
all
sir.
faculty members, and you please go through that website, see it, and try to find whether you can also initiate some of the activities, at your the level at your institute, and always we can collaborate, we can work together. There is no limit. Uh, that's all. Thank you.
Thank you, sir. According means as per the request from the participant, please share the PPT from in my Google so that I can
Okay,
share with them.
okay, I'll do that. I'll do that. Plus,
Okay,
but
thank you. Thank you so much, sir.
but only one concern to this, because I don't like the these days the social media things. So do not put it in the Facebook or the LinkedIn, anywhere. You can mention me, but do
Okay,
not put the video or the this one. So you can consume it as per as your understanding requirement. Okay, this is my
Yes, sir. Yes, sir. Yes, sir.
Thank
Okay.
you.
Thank you. Thank you, sir.
So can I leave now? Any question from anybody, any participants? If you have got it, because I can see a large number of people are present today. So if any question is there, I'll be more than happy to answer.
Thank you, sir.
Sir, I
So,
have a question, sir. Sir, good evening, sir.
Yeah.
Hello. I am Dr. A. Tanigasalam from Amat University, Chennai, Tamil Nadu.
Okay.
The Chart GPT, no, it's one of the AI tool, no? Yes, sir. Chart GPT.
Ah,
Chart GPT. Sir, the AI is only data collection and within seconds it give answer, no? That is AI, no?
yeah.
But you are telling AI is the machine point of view. You mentioned
What
AI
I
is
yeah?
Uh, AI is a data collection and give answer within 2 minutes or 1 seconds. Is it correct, sir? AI.
AI.
Yeah. The chat
Yeah.
GPT, whatever question asking, whatever
Uh,
question you're putting, within the seconds it will reply. No. So it's a data
no,
collected.
no.
Oh, yeah.
So you see that what Chat GPT or any GPT thing right now, it doesn't have any computation. You have to understand that. It cannot do any computation. What it does is that it tries to find out the information collecting from the different databases and all.
Oh,
Okay, so if you want to, if you give a problem statement to ChatGPT and like a beam is there, so this much of load, find out the stress level at each and every point, ChatGPT will not be able to do it.
yes, sir. Yes, sir. Okay.
Okay, so the AI, what we are trying to do it is the more of scientific in nature, in a sense, like why I'm saying scientific in nature, because manufacturing applications we need to process that information, and information means the solving the physics of the process. Okay, so
Yes,
for solving the physics of the problem, there will be a lot of computation requirement.
yes,
How
sir.
can you get to know the machine, the tool where is happening, or tool
Yes,
where tool is going to fail?
yes,
That
sir. Yes,
you need to understand the tool failure mechanisms. You need to understand that how the crack will propagate.
yes,
So that physical information is also embedded along with the information that we collect through the sensors. That's why it is called the hybrid method. So those information, if you cannot do this, then the model will not be very much accurate. Can
yes,
have something. So the people are putting concern on the chat GPT and other things. Then what is the sanctity that the information is right?
yes, sir. Yes,
If
sir. Yes, sir.
it is giving some information, we are getting excited because we don't need to do any work.
Yes, sir. Yes, sir.
If someone is giving food, giving it ready in front of you, you always get happy. But what is the quality of the food? If you are very much concerned about it, whether you are getting the right food or not, if you are very much fussy about it, then the problem comes up. So the
Oh,
chat GPT thing directly cannot, so that's why people are working on the sanctity of the model. Acceptance of the chat GPT, it can be considered as a recommendation.
yes, sir. Oh,
Can be considered as a recommendation. Like in your process, if I say that I would, you are, because we all human beings are basically restricted by our own individual level of thought process. We cannot think beyond our thoughts. So
yes,
if some references can be given, some recommendations can be given, then your development on that thought will be much more better. And that's why people refer, like if I can get to have some write up, some draft, that would be good. Then I can modify it.
yes,
But
sir.
if I start writing the draft itself from the beginning, then I'll scratch my head. The ChatGPT, in that perspective, it is helping a lot. But you have to have a sanctity on that. You have to put a question mark. You have to take it a pinch of salt. Like it's not all the time correct.
Yes, yes, yes.
Okay, thank you.
Sir, any AI tool for machining invented or not, sir? AI
Huh?
tool.
Yeah,
AI
tool.
tool, any AI tool invented for machining purpose?
That's why I told now you have to do research on it. There is nothing available as of now in the market.
Oh,
Specifically for the Indian market, it is not there. So you need to do research. That's why the first slide is that I wanted to create awareness that this is the potential of AI, and All of you must start working slowly with a baby step approach. You must, the work. If you think that I'll be doing a very big thing at the first stage, then you'll be making a mistake. But you must start working. If you don't start, you will not be able to understand. If you don't understand, if you can't understand, then you'll not be able to progress. If you cannot progress, then everything will be coming down.
Okay,
So
sir.
all of us need to progress. All of us need to understand. All of us need to work hard. Okay.
नेक्स्ट होता कहेंगे देखो दिया
What is that? I could not follow.
Thank you, sir. Thank you for your good answer, sir. Thank you.
Thank you.
Sir, one more question.
Yeah.
Sir, this is Venkatesh from Tamil Nadu, FDP-Mechanical College of Engineering.
Okay.
Sir, the question is digital twin technology. How do we can integrate the augmented reality and virtual reality? How do we can relate
Yeah.
this
So
principle, sir?
yeah. So you see, these are all not. There is no specific format or rules to this one. You have to customize it as per your need. People are facing difficulty in the digital twin perspective, how to integrate the physical, information which are collected from the simulation model into your
Okay.
the data model, because the simulation, we all know, takes a lot of time. Data can be collected instantly. So how can I process the simulation data, and digital twin has to work in the real time. So
Okay, sir.
there is no specific format. That is, even in the digital twin also, in our book, Mr. Rosmi Roy, please mute your microphone. Yeah. So we have clearly mentioned in our book that the digital twin, there is no specific format, there is no specific rule. People are all exploring, trying to gathering information and making it useful for that particular problem, the statement. It is not that the specific rule will be applicable for every situation. So I cannot say any specific answer to that.
Okay, sir. Okay. Yeah, okay, thank you.
Uh,
Okay then. Yeah.
Thank you, Professor S.K. Pal, sir, for coming in, means accepting our invitation and means obviously addressing